Okay, we are on one of our last lessons of the software engineering unit, which is called functions. So today we're going to talk about functions. Okay, so a function is a block of organized, reusable code that is used to perform a single related action. So we're going to break that down in just a second, this definition. So a block of organized, reusable code. So we're going to look at this. This is a very simple function. I know it doesn't look very simple, but what it does is it draws a 5-pointed star. Okay, so it's a block of code, and I can tell that these lines 3 through 12 are part of the function because they're all indented. And it's just a simple function that's going to draw us a star. And we put these organized blocks of codes inside of functions so that we don't have to keep copying and pasting whenever we want a 5-pointed star. I don't have to keep copying and pasting it in order to get that. So let's look at what this does here. So this little GIF that's running on the side here is exactly what this does when it runs. Okay, so this area right here in the red block, this is the code that's inside the function. Again, you can tell that by the tabbing. You can see that these lines 10 and 11 are tabbed in one other indentation level because they are, not only are they part of the function, they are also part of the loop for I in range 5 loop. Okay, so all this does is it tells the turtle to have the pen up. It tells it to go to a really specific position, 100, 100. It puts its pen down. It turns the outside angles of a 5-pointed star. It sets the color. It begins the fill 5 times. It goes forward, turns 5 times, and then it ends the fill. So it fills in the shape when it's finished. And that's the end. We're going to talk about what line 13 is in a second. Okay, so it's a block of organized code that performs an action. That's literally just what a function is. And we use functions, by the way, in order to simplify our code. So we've seen places before we've made the snowflake patterns where we had to copy and paste. Each time we wanted a snowflake, we had to copy and paste the block of code that allowed us to make the snowflake. But that's redundant. We don't need to do that over and over again. And if there's anything that programmers don't like, it's redundancy, like doing things without taking up more lines of code than is absolutely necessary. Okay, so why do we need functions? This goes back to what I was just talking about. Well, it's reusable. All right, when we looked at we did the Starry Night tutorial, we made a function up here. I can tell it's a function because it has the word def in it. And we asked it to take a number of items in, and we're going to talk about what that is. And then I set in motion like what this function was. This was a block of reusable code. Lines 6 through 15 are all these code that's reusable. Line 16 is not part of the function because it's against the left margin, so it's not indented in. Then what I did with my while true loop is I set the points, the size, I randomized all these things, randomized the location, and then I called the draw star function, right? This is the point at which I ask this block of code to run, all right? Now the while true loop, we know that runs forever and ever and ever because the condition is always met, because it's always true. So this is gonna run indefinitely, right? Until I close my browser window. So the whole point of this is I made this block of code that was reusable, and then in the while true loop, I just called that block of code to run again and again and again with different randomized numbers that told us the points, the size, the color, and the position of the X and Y. Okay guys, here's your Easter egg. You'll need that for the check for understanding. Okay, let's talk about a pretty simple example here. So we have a little short function here that's, the name of it's called line. And all it does is it goes forward, it stamps, it turns right, and it stamps. Okay, so we're gonna use this example and go over every part of it so that you understand how we build a function. So first of all, we start the function with the keyword def. Now that's pretty critical. That is it's coded in blue here. It's colored in blue here in the development environment of Replit because it is a keyword. Okay, so you always start functions with the keyword def, and that stands for define. The word that comes next, there's a space in between it, and then the word that comes next is the name of the function. You can name it anything you want, but it's going to follow the same naming guidelines as does a variable. You can't start with a letter. You can't have spaces in it. You can have a letter inside of it, just can't start with one. And there can't be spaces, but you can use underscore to separate words, okay? Now, these two things right here are called parameters, okay? The function needs two numbers in order for it to run. So it needs the numbers a and b. Sometimes functions don't have to have any parameters, and sometimes they do. It's going to depend on what you want the function to do. Now, I don't want this to be a boring function. I want, every time I run it, I want to be able to give a different length of the line and a different angle for it to turn. So if I always want it to be 190, then I could put 100 in here for A and 90 in here for B, and I would just have line, open, and close parentheses. You do have to have the parentheses, but you don't always have to have variables inside of it. So these are going to be the letters that represent the numbers later on. But if you do have them, those are called parameters. Okay, so A and B are called parameters. Okay, the parts of a function, so the forward, right, and stamp, these are all the actions that you want the function to do. And they are part of the function because they are tabbed into the function. There's one level of tabbing, which is the 4 spaces, or you hit the tab key. Now, notice that the function's first line is like the for and the while and the if and the elif statement where it has a colon, and we can tell the containment within it by the tabbing, right? This white space, the space in front of it's called white space. White space in Python indicates containment. So if you want something to be contained in a for loop, for example, you indent it, right? Or if you want something contained in a function, you indent it. It's all that block there. That way I can tell. I know that line 10 is not part of the function because it is against the left margin. Okay, so that's all the stuff that you want the function to do. Now, line 10 is really interesting. So the whole purpose of a function is that you have it sitting in your program, but you don't necessarily want it to run immediately. Okay, or the other thing is that you may want it to run it like a bunch of times. So when you create a function, by default, it doesn't run. It just sits in your program, and as soon as when the program is being read from top to bottom, as soon as it hits that keyword def, it doesn't even look at any of the indented blocks here. The program doesn't read any of those until it needs to. And you tell it to run the program, or to run this little block of code, by saying the name of the function, which is line. And for us, we have to actually give it numbers to replace A and B for. So I want to replace A with 100, so I'm going to ask it to move forward 100, and replace B with 90, so I want it to turn right 90. So 100 represents a pixel value, whereas 90 represents the degree value. And you can mix and match these parameters all you want. You could have one be a string and one be a number. It just depends on how what's happening when you replace it. Okay, that's where it's going to throw an error. If you put 100 into here and it's a command that doesn't take a number, then it's going to be a problem. Okay, line 10 is the vocabulary that we use. We say it's calling the function. So I call the function by saying its name and telling it what to replace the arguments with. All right. Replace the parameters with. So A and B are called parameters. They are the placeholders. When I put specific numbers in, like 190 are called arguments, right? So it's kind of a subtle difference. Like A and B are variables. They're placeholders or stand-ins. The actual, when you call it, you actually have to put the arguments in that you want to replace it with. So this right here is another function. So this line 1 creates a function and names 2 parameters. So it names A and B. What I want the function to do is I want it to create a variable C that is the addition of A and B. So line 2 says, okay, inside the function, whenever you run it, create another variable C and add together A and B and put it into C. And then the third line is I want it to print C. Okay? Now, if I didn't have line 5 and I hit run, nothing would happen, because you haven't called the function. So the functions just sit in your program until you tell it to be called. And that's like the default of most programming languages. They don't auto-run for you. They wait until you need them, and you tell them that you need them by calling it, like on line 5. So line 5 calls the function, it makes it run, and it gives it the arguments, it gives it the arguments of 10 and 3. So I pass those arguments into the parameters of A and B there. And when I get that, because I asked it to print, it's going to go ahead and print 13. Now, I could call it another time. On line 6, I could say add, and I could say 20 and 4. And then it would print 24 for me, because it's the sum of the two numbers, right? So depending on the arguments I give to it at runtime, the outcome of the function is going to be different. And that's what you want the function to do, right? You don't want it to just have one outcome every time. That's a pretty boring function. That's why you give it these parameters up here, so that every time you run it, it will do something different. Okay, and that's the end of the lesson. You guys are just going to go ahead and check yourself on the Check for Understanding quiz.